Dear students, welcome to the lecture series on the topic Engineering Graphics. Today we are going to discuss about isometric projections. I am Dr. IPS Ahuja, Professor, Department of Mechanical Engineering, Punjabi University, Patiala. Now here we have been provided with the two orthographic projections of the solid, that is the front view and the top view. So using the information available with us through these two orthographic projections, we are required to draw the isometric projections of the solid. Now in the isometric projections, the front face, the side face and the top face of the solid, they will be clubbed into a single 3D isometric construction. So we need to evaluate the dimensions of the front face, top face and the side face of the solid. Now as we look at the solid in the front view, so we observe that the length of the solid happens to be 60 millimeter, while the height of the solid, it is equal to 55 millimeter. So the front view face dimensions will be 60 millimeter by 55 millimeter. Now in the top view, we observe that the length of the solid, it is equal to 60 millimeter, while the width of the solid, it is equal to 55 millimeter. So this is the width of the solid. So we are going to get the top view face dimensions of the solid will be 60 millimeter by 55 millimeter. The side view face dimensions will be width equal to 55 millimeter and the height of the solid equal to 55 millimeter. So from the right hand side, we are going to observe a square face which is having an edge equal to 55 millimeter. Now let us discuss the basic geometry of this component. Now as we look at the front view of this particular solid, so we work out that there is a horizontal wave which is lying at the base of the solid, and this horizontal wave, when we look at this horizontal wave from the top view, so we find that there is a rectangular hole over here. So this is the rectangular cross section hole which is lying at the center of the wave and it is appearing on the front side of the object, right? So this is the horizontal wave which is lying onto the base, and besides this horizontal wave, we have got a vertical wave into this solid over here on the rear side. So we can see that on the rear side there is a vertical wave, and this vertical wave, it is also not a straight wave, because into this vertical wave again we are having a rectangular slot which has been provided on the right hand side of this vertical wave. So once rectangular slot is there in the horizontal wave which is lying onto the base, and another rectangular slot has been cut in this vertical wave towards the right hand face of this particular solid. Now we are going to locate the front view along the x-axis, and the width will be located along the z-axis into the isometric construction over there, because the vertical wave we are going to draw on the back side, and this rectangular slot which we have got on the front hand side over there on this horizontal wave, this horizontal slot will be provided along the x-axis into the isometric projection. So as we know that the front view dimensions are 60 millimeter by 55 millimeter, so we are going to draw the 60 millimeter length along the isometric x-axis, and the 55 millimeter height of the solid has been drawn along the y-axis over here. So the front view face, this is going to be the front view face. So the front view face will be located along the xy plane into the isometric projection. Similarly, the right hand side view face, it will be located on the right hand side. So we are going to draw the width of the solid, that is equal to 55 millimeter along the z-axis, while the height equal to 55 millimeter will be drawn along the y-axis. So we can say that the right hand face of the solid will be located between the YZ plane over here, and the top face or the bottom face, they will be oriented along the XZ axis. So we know that the dimensions of the top face, they happen to be 60 millimeter by 55 millimeter. So 60 millimeter has been drawn along the isometric x-axis, that is the length of the solid, and 55 millimeter width of the solid has been drawn along the z-axis. So this is going to be the location of the base of this particular solid, which will be along XZ plane. Now in order to draw the isometric projections, we need to draw first of all an isometric scale, and using this isometric scale, we need to convert all the true lengths which are available with us in this orthographic projections. And once we are able to convert these true dimensions into the isometric length dimensions, only then we can start with the construction of the isometric projections of this particular solid. Now let us move on to the construction of the isometric projections of the solid. So first thing we need to do is, we have drawn a ground line which is the datum line over here. So a horizontal ground line or the datum line has been constructed, and we have marked an origin point over here onto this horizontal datum line, and from this origin we are going to draw the isometric x-axis towards left at an angle of 30 degree. Similarly, from this origin point we are going to draw an isometric z-axis with an angle of inclination equal to 30 degree with the ground over there or the datum line. Then from this origin we'll draw a vertical y-axis, and this y-axis has been drawn perpendicular to the ground. Now we know that we are going to draw the front face towards the left hand side. So we are going to mark the length of the solid equal to 60 millimeter along the x-axis. So we have drawn this length equal to 60 millimeter along the x-axis, and the height of the front view face of the solid we have drawn as 55 millimeter. Now in order to complete this front view face, another isometric edge has been drawn parallel to the y-axis, and the length of this edge is equal to 55 millimeter. Similarly, another isometric edge measuring 60 millimeter has been drawn parallel to the x-axis. So this completes the construction of the front view face of the solid over here. Now next we move on to the construction of the right hand side view face. So we know that the dimensions of the side face, they are 55 millimeter by 55 millimeter. So the width of the solid, which is equal to 55 millimeter, has been drawn along the isometric z-axis, right? And the height of the solid, it is equal to 55 millimeter. This has been drawn along the y-axis. So in order to complete the right hand side view face, we have to draw this isometric edge measuring 55 millimeter parallel to the z-axis, and this isometric edge which will be measuring again 55 millimeter, this has been drawn parallel to the y-axis. Now we have to draw the top face of the solid. So we know that the dimensions of the top face of the solid, they happen to be 60 millimeter by 55 millimeter. So we have already drawn the length of the solid equal to 60 millimeter, and the width of the solid is equal to 55 millimeter. So two isometric lines we need to draw parallel to z-axis and the x-axis, so that the top view face of the solid can be completed over here. Now having completed the top face, we need to complete the bottom face over here, that is the bottom of this particular solid. So in order to complete the bottom, so this is an isometric edge measuring 55 millimeter which has been drawn parallel to the y-axis. This is another isometric edge which measures 55 millimeter. This has been drawn parallel to the z-axis, and this isometric edge which measures 60 millimeter, and this is parallel to the x-axis. This has been drawn. So this is the base of the solid. Now having completed the base of the solid, so all the faces of the solid, they have been completed. So this information has been transferred onto the isometric projection, and we have been able to obtain a square prism over here. So this square prism construction is going to contain all the elements of this particular solid over here. So as we have already discussed, we are going to divide this construction into two webs. One web, it is the horizontal web, which is having this shape. So please check, this is the shape of the horizontal web. So this horizontal web, it is lying on the base of the solid. And what is the height of this web? The height of this web, it is equal to 15 millimeter. Now we are going to draw a ring over here, which will be forming the guidance to construct this base web or the horizontal web. So the height of this web has been drawn as 15 millimeter from the bottom of this object over here. So this is the height of this web. That is the top surface of this web. It will be located at a distance of 15 millimeter from the bottom. So having located this horizontal web, now we need to move on to the second web over here, which is this web. So please check, this is the second web. So this web is located at a distance of 35 millimeter from the bottom. So this is a distance of 35 millimeter from the bottom, and this web will be required to obtain this rectangular slot in the vertical web, right? So in order to draw a rectangular slot and this horizontal surface, we need to locate over there. So in order to locate this horizontal surface in the vertical web, we have drawn another ring over here, which is located at a height of 35 millimeter from the bottom of this particular object. So now having obtained these two rings, now I need to locate the vertical portion of this vertical web. So we can see that this top portion, so this top portion of this vertical web, this measures 30 millimeter. So this distance is available with us in the top view over here. And besides, this length equal to 30 millimeter. So this is the length of this particular top surface over here. The width, this web is measuring width equal to 20 millimeter. So the length we have marked as 30 millimeter of this cross section at the top surface of this particular component. So this is 30 millimeter, and the width of the web, it happens to be 20 millimeter. Now two projection lines I am going to draw at the top surface. One will be indicating the length of the top surface of this web, which is this section or this section I can say, and another construction line I will be drawing at a distance of 20 millimeter. So this 30 millimeter projection line which I have drawn over here, it is corresponding to this edge over here. So we are going to confirm this edge while we draw this projection line over here. Next, another projection line we are going to draw from this point up to this point, so that we can define or we can fix this width of the top surface of the web as 20 millimeter. So once we draw this particular projection line, so we have been able to identify this top surface of this vertical web onto the isometric projection construction over here. Now having drawn this particular top portion, now I need to move down. So I know that the total height of the solid happens to be 55 millimeter. The height of the horizontal web which was lying onto the base of the solid, so this is the horizontal web. The height of this horizontal web which is lying onto the base of the solid, it is equal to 15 millimeter. So from this point or from this corner, I need to move 40 millimeter downwards over here, so that this vertical edge can be obtained on the rear side of this particular solid. Now what I have done, I have marked this distance equal to 40 millimeter. So this distance will be starting from here and it will be ending up on the top surface of this ring over here. So please check, I have drawn this vertical edge of the vertical web, which is going to start from this corner, that is this corner over here, and it is going to end at the top surface of the horizontal web over here. So starting from here, I have been able to draw the vertical edge terminating at the top surface of the first ring which I had drawn at a height of 15 millimeter. So this edge has been located. Now having located this vertical edge of the vertical web over here, now I need to evaluate this vertical edge starting from this point and starting from this point over here. So from this point I am going to draw a vertical projection line. This vertical edge will be having the height which is equal to 20 millimeter. We can check the total height happens to be 55 millimeter. The top surface which is corresponding to this ring number 2, it is lying at a height of 35 millimeter. So this height over here, it is equal to 20 millimeter. So as we move down 20 millimeter, we are able to reach the top surface of the ring number 2. And similarly, from this point also, I am going to draw the vertical projection which will be having the vertical edge height equal to 20 millimeter. The moment I obtain this point and this point, another isometric edge I will be drawing over here parallel to this edge over here. This edge means z-axis. So parallel to the z-axis, I am going to join this edge, and while I join this edge, this vertical wall which is appearing as an edge view in the front view has been obtained. So this vertical wall which is appearing as an edge view has been obtained, and then now from this point I need to move on to the front portion over here. So from this point and this point, this web, it will be lying on the top surface of the ring number 2. So this is the significance of drawing the ring number 2 over here, so that I can locate this horizontal surface which is lying on the top of ring number 2. So in the front view, once again, this rectangular surface, it will be appearing as an edge view looking from the front. So this is an edge view of the surface which will be visible to us from the front view. So this surface has been obtained, this surface has been obtained over here, right? And this horizontal surface has also been obtained. Now having obtained this, now I need to move down. So I need to move down further by 20 millimeter. So from here, I move down 20 millimeter. From here, I move down 20 millimeter. So I'll be able to reach the top of ring number 1. Similarly, you can check, I have joined this and I am going to move down. And this way, this surface, which is again a vertical edge, but it is not a vertical edge, it is the square surface. It is this surface which I had obtained. So corresponding to this vertical surface, I have been able to obtain over here, this is the vertical edge which I am going to get in the front view. So having obtained this, now another thing I have done, through this point, I have drawn a horizontal line over here. This is the horizontal edge. Again, an isometric edge has been drawn parallel to the x-axis. So this gives me the completion of this vertical web, which is having a rectangular slot which has been cut on the right hand side of this vertical web. So this web has been completed. The construction of this vertical web having a rectangular slot has been completed now. Now my next objective is to obtain a rectangular slot right here on the front side corresponding to this top view. So we can check that into this horizontal web at the center, I have to obtain a rectangular slot. 30 millimeter will be the length of the slot, 15 millimeter will be the width of the slot, and 15 millimeter will be the height of the slot. So these are the dimensions of this rectangular slot. So in order to obtain this rectangular slot. So once again the procedure is simple. What I am going to do, that I am going to have this distance along the length. This distance along the length, I know that this distance along the length happens to be 15 millimeter. So this distance I have marked as 15 millimeter, which is the length, and this is the width of the slot. So the width of the slot is equal to 15 millimeter. So what I have done, on the front face I have marked this distance from the right hand side corner equal to 15 millimeter, and parallel to the z axis I have marked this depth equal to 15 millimeter. So this is the depth of the slot which has been marked over here. So the depth of the slot has been marked parallel to this depth. So this is my z axis. So parallel to the z axis, another projection line has been drawn which will be measuring 15 millimeter, and then parallel to the x-axis, which represents the length of the solid. So this is the length of the solid, and this is my x-axis. So another isometric edge has been drawn, and this edge, it is going to measure 30 millimeter over here. So this is going to measure 30 millimeter, and once I reach this point, I will be getting back to the front face, and this edge, it is again parallel to the z-axis, and the length of this edge will be 15 millimeter. So that this is the completion of the rectangular slot. And as we all know, this rectangular slot, it appears on the top surface of our horizontal web. So that is why on the top surface of the horizontal web, so we have drawn this rectangular slot, and from here I am going to draw the vertical edges so that I can obtain the height of this particular slot over here. So the dimensions regarding the width and the length of the slot, they have been projected on the top face of the horizontal web over here. Now once I have obtained this, now the vertical edge, so please check, this is the vertical edge which has been drawn over here. So vertical edge from the front has been drawn, but this edge will not be visible. That is why we have not drawn this particular edge, but this edge will be visible, as well as this edge will also be visible. So this edge will be visible to us, and this edge will be visible to us. And again, the height of this edge, and the height of this edge will be equal to 15 millimeter. So please check, this is the height of this rectangular slot. This is equal to 15 millimeter. This is height of the rectangular slot. It is also equal to 15 millimeter. So this edge also represents the height of the slot. And finally, I need to join this over here, this edge over here, so that I can complete this vertical face of the slot which is visible to the observer. So this completes the construction of all the edges regarding the horizontal web, the slot in the horizontal web, the vertical web, and the slot in the vertical web. So all the elements of the component which was provided to us through these orthographic views, they have been obtained. Now I am going to start with the darkening of the edges so that I can evaluate what are the elements which are visible to the observer. So this top face of this vertical web, that is this one, this is a rectangular face, so this is visible to the observer. So I have darkened this top face. Then the height on this side, it is equal to 40 millimeter. So this edge, it is visible to the observer. I have darkened this, and the height on this side, it is equal to 20 millimeter. So I have darkened this as 20 and this as 20, and again I am going to darken this one. So this is my horizontal surface over here, right? So this is my horizontal surface which appears in the top view like this face, and in the front view this horizontal surface will be appearing as an edge view in this orthographic projection. And then I will be moving down over here. This height, it is equal to 20 millimeter, and on this side this height, it is equal to 35 millimeter. And then let me complete the horizontal part of the web. So from the side view, this web will be appearing like this, and from the front side, this is the projection corresponding to this face, and this face is visible to the observer in the front view, whereas in the top view I am going to get the edge view of this particular face over here. Similarly, you have this particular rectangular slot. So this rectangular slot has been darkened because this is visible to the observer. So this is again the vertical wall which corresponds to this surface. Okay. So this surface of the slot, which is the vertical surface of the slot, it is visible to the observer. So this has been darkened. Whereas this complete horizontal surface, which measures 30 millimeter length and 15 millimeter height. So part of the surface has been covered by this vertical leg of the horizontal web. So that is why we are not able to see this as a complete one. And then this is second portion of the bottom web over here, and then we join this one. So this gives the complete construction of the solid. Okay, so with this we have been able to complete the construction of the solid. And into the solid, as we had discussed, this is the horizontal web in which a rectangular slot has been cut, and there was another vertical web over here in which another rectangular slot had been provided over here. So this way we have been able to complete the construction of the isometric projections of the solid, wherein the front view and the top view orthographic projections, they were available with us. So I hope that through this discussion you would have understood about the procedure to develop the isometric projections of the solid when the orthographic views of the solid, they were available. So this is all for today. So we'll be continuing with few more examples regarding the construction of the isometric projections in the coming lecture. So thank you very much. Thanks a lot.